previously, we were able to establish the Laplace transform of e to the power of t. This is actually equal to 1 over s minus 1. Please check the previous video in the process that allowed us to come up with this equivalence. Actually, again, this is taken from the formula of 0, or you will have the Laplace transform of any f of t is equal to the integral from 0 to infinity. Let me rewrite this to make this better. You have f of t is equal to the integral from 0 to infinity of e to the power of negative st. Then you have your f of t dt. Okay, this time we have here two different forms. The Laplace transform of negative 3 e to the power of t and the Laplace transform of 4 e to the power of t. And hopefully, at the end of the video, we can generalize the Laplace transform of any expression expressed in this manner, c e to the power of t. Because as you can see, our identified items here just have different c, because this could be written as 1 et, and we would like to generalize that could also be true for all forms. Okay, so this is our goal at the end as well. So let's start with the Laplace transform of negative 3 e to the power of t. Again, this will follow the formula, the integral of from 0 to infinity of e to the power of negative st. Then your function here, negative 3 e to the power of t dt. Now, since this is a constant, we can always take it out. Okay, the integral from 0 to infinity, pardon for this, we will have it later, e to the power of negative st, then you have e to the power of t dt. As you can see, this form, okay, was actually identified already in the previous video. This is actually the form that is good for the Laplace transform of e to the power of t, because this is your f of t here, and it is already identified as 1 over s minus 1. If you're not convinced with that, please leave the video, or we could also again try to include it here. But since this is already identified, again, you have that in the previous video, we will have here this form, negative 3 times the Laplace transform of this. By the way, what happened here was actually we combined the exponents, or we combined expressions with the same base, so we add the exponents, and all the rest is already part of the previous video. Again, please look into that video, so this video here will not be too long, because we would like to generalize this form later. This is just negative 3 times 1 over s minus 1. In short, the Laplace transform of negative 3 e to the power of t is just equal to negative 3 over s minus 1. Take note of that here. Similarly, for our second item, the Laplace transform, sorry, I have a little bit trouble with writing that. The Laplace transform of 4 e to the power of t is again expressed in this manner. 0 to infinity, e to the power of negative st, then you have 4 e to the power of t dt. With 4 being a constant, we can move it outside. 0 to infinity, e to the power of negative st, e to the power of t, and then dt. Again, this was already taken, charged by this form here. Because again, this would become e to the power of t, and it will have this form similar to this. So basically, it's just 4 times this equivalent to 1 over s minus 1. Hence, the Laplace transform of 4 e to the power of t is equal to 4 over s minus 1. Now, we are ready to generalize the Laplace transform of c e to the power of t for any arbitrary constant c. When you look at the first form, 1, okay, this is just equal to 1 et, your exponent here is 1, right? Or as a factor of 1. But if it's negative 3, that is what happened here on our numerator. Similarly, for 4, that also appears in our numerator. So general form for this is that whatever c here will be your numerator, and your denominator is just s minus 1. This is a general form for the Laplace transform of any function c times e to the power of t. This is what we did for this video here. Please be guided. Thank you very much for watching.